Hello everyone, this is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about random variable. So, what is random variable? Before going to start random variable, first of all, we will discuss about random experiment and the sample space. So, what is random variable? So, already we have discussed in the first session. So, in that, what is random experiment? An experiment is said to be random experiment if the result is not unique. That means more than one result should be there. More than one result. More than one result. More than one result is called random experiment. So, what is sample space? Collection of all possible outcomes is known as sample space. If we toss a coin, we will get two possibilities. First one is head and second one is tail. So, the sample space consists of total elements. So, those are head, tail. So, this is called as sample space. Collection of all possible outcomes is known as sample space. It is denoted with S. Okay. So, now coming to the definition of random experiment, random variable. Coming to the definition of random variable, in any random experiment, the sample space associated with the real number is called random variable. It is denoted by capital X or small x also. Okay. So, what is real number? Real number is always denoted with R. Sample space is denoted with S. In any random experiment, the sample space associated with the real number is called random variable. A sample space associated with the real number is called random variable. For example, tossing two coins. If we toss two coins, we will get how many possibilities? 4 possibilities. So, what are they? So, head, the sample space consists of head, tail, head, tail. So, we will get how many possibilities? 4 possibilities. So, let us consider our event, our random variable is getting number of heads. Our random variable is getting number of heads. So, here I am writing head, and head, tail, head, tail here. Okay. So, in this experiment, how many heads are there? 2 heads are there. Okay. So, but we need only number of heads only. So, that's why in head we have 2 heads. In head tail we have 1 head. In tail head we have 1 head. And in tail there is no head. That means that is 0. Okay. So, this is nothing but all of you know that this is our sample space. So, sample space yes is head, tail, tail. So, that is associated with the real number. That is associated with the real number 2110. Okay. So, this is called random experiment. So, what is random experiment? The random variable. So, the random variable is nothing but in any random experiment. So, this is our random experiment. In any random experiment, the sample space associated with the real number. The sample space associated with the real number is called random variable X. Okay. So, here this is sample space and these are real numbers. So, therefore, the sample space associated with the real number is called random variable. So, the random variable is denoted with 0, 1, 2. So, therefore, the random variable is here 0, 1 and 2. So here the random variable is 0, 1, 2. So if we tossing 2 coins for getting number of heads, then random variable is 0, 1, 2. So next example is tossing 3 coins. Tossing 3 coins. So tossing 3 coins is our random experiment. So what is the definition of random experiment? So more than one result should be there. So that is called as random experiment. So here what is our result? The sample space associated with head, tail, head, tail, head, tail, head, tail, head, tail, head, tail. So total how many possibilities are there? 1, 2, 3, 4, 5, 6, 7, 8. So total possibilities are here 8. So this is our sample space. Means if we toss 3 coins, we will get these possibilities. This is our outcome. So collection of all possible outcomes is sample space. So this is our sample space. Head, tail, head, tail, head, tail, head, tail, head, tail, head, tail. Okay. So what is our event or what is our random variable? So for random variable, so we need our event. So that is our event is. So here our event is getting number of tails. So we should focus on only tails. So getting number of tails. So here how many tails are there? There is no tail. Head, there is no tail. So that's why that is 0. In head, tail, we have only one tail is there. In head, tail, head, we have also only one tail is there. So here also same head, tail, tail, head. Here also we have only one tail. Head, tail, here we have 2 tails. In tail, head, tail, we have 2 tails. In tail, head, we have 2 tails. In tail, we have 3 tails. Okay. So this is our this is our real number. So here real numbers are 0, 1, 2, 3. So sample space associated with the sample space associated with the real number is called random variable. The sample space associated with the real number is called random variable. So here x is nothing but getting number of tails equal to. So what is our random variable here? So 0 and 1 and 2, 3. So 0, 1, 2, 3. So this is our random variable. So next, types of random variables. Actually, there are 2 types of random variables are there. First one is discrete random variable and second one is continuous random variable. So first one, discrete random variable. So what is discrete random variable? A random variable is said to be discrete if the range of random variable is finite. Example, getting number of heads if we toss 2 coins. If we toss 2 coins means we will get how many possibilities? So the sample space consists of 4 possibilities. Those are head, tail, head, tail. So we have 4 possibilities. And so what is our random variable? If we toss 2 coins, the getting number of heads. So we should focus on only heads. So what is our sample space? Our sample space is head, tail, head, tail. So this is our sample space. And so here how many heads are there? Here we have only 2 heads. So here we have 2 heads. So this is our real number, right? So here how many heads are there? 1 head. Here how many heads are there? 1 head. And here how many heads are there? 2. How many heads are there? There is no head. That means 0 heads are there in tail. So therefore x equal to, our random variable x equal to 0, 1, 2. 0, 1, 2. So this is our random variable 0, 1, 2 if we toss 2 coins when getting number of heads. So here how many random variables are there? Only 3. So if the range of random variable is here finite. If the range of random variable is finite, then we can call it as discrete random variable. Okay. Next. Second one is continuous random variable. A random variable is said to be continuous if the range of random variable is interval of 2 real numbers. The range of random variable is interval of 2 real numbers. Example. The height of students in a classroom may be 4 feet to 6 feet. So in classroom, so many students are there, but their heights are 4 feet, 4.1, 4.2, 4.3, 4.4, like that, 5 feet up to 6 feet. More than 6 feet also may be there. So this can be written as x is from 4 to 6. That means the range of random variable is here interval of 2 real numbers. Interval of 2 real numbers, that is, those are 4, 6. So this is called continuous random variable. Next definition is probability distribution or probability function. If x is a random variable, then the function f of x equal to p of x equal to xi is called as probability distribution or probability function. So f of x equal to p of x equal to xi. So that is equal to p of x. So this can be written as, this can be called as probability distribution or probability function. Simply we can say that the probabilities for the random variable, x is nothing but here random variable. Probabilities for the random variable is known as probability distribution or probability function. Or we can say that if f of x equal to, if x is a random variable, then the function f of x equal to p of x equal to x or p of x equal to xi or p. So or p of x equal to xi is called as probability distribution or probability function. Next, types of probability distribution. There are 2 types of probability distribution. First one, discrete probability distribution. Second one, continuous probability distribution. So what is discrete probability distribution? Discrete probability distribution, or we can call it as very important one, probability mass function or PMF. Discrete probability distribution is also known as probability mass function or PMF. So that means if x is a discrete random variable, if x is a discrete random variable. So what is discrete random variable? So what is discrete random variable? If the range of random variable is finite, then we can call it as that is discrete random variable. If x is a discrete random variable, then the probability distribution f of x equal to p of x equal to xi or p of x equal to x, or simply we can say that p of x is said to be probability mass function or discrete probability distribution or PMF, probability mass function, if it has the following properties. We have two properties here. So first one is f of x greater than or equal to 0, and second one is summation f of x equal to 1. Or we know that f of x is nothing but p of x. So p of x greater than or equal to 0 or summation p of x equal to 1. So these are our two properties. If we satisfy these two properties, so then we can call it as that is probability mass function, or we can say that that function is probability mass function. If the function is probability mass function, if it should satisfy these two properties. First one is p of x greater than or equal to 0 or summation p of x equal to 1. Or we can say that f of x is nothing but we know that f of x is p of x, or f of x greater than or equal to 0, or we can write p of x equal to xi greater than or equal to 0, summation p of x equal to xi is equal to 1. So for I equal to 0 to n. Okay, so next one is continuous probability distribution. Continuous probability distribution or probability density function or PDF, probability density function. So this is also very important in random variable. Let us consider if x is a continuous random variable, that means the range of random variable is continuous, or the range of random variable is interval of two real numbers. What is continuous random variable? If the range of random variable is continuous, or the range of random variable is interval of two real numbers, is known as continuous random variable. So here continuous probability distribution means if x is a continuous random variable, then the function or then the probability distribution or probability function f of x equal to p of x equal to xi or p of x equal to x or p of x equal to p of x is said to be probability density function or PDF or continuous probability distribution. If it has the following properties. Here we have two properties. First one is same like discrete probability distribution or probability mass function. So what is our first property? F of x greater than or equal to 0. Or we can say that P of a. We know that f of x is nothing but P of x, right? So that is P of x greater than or equal to 0. So this is our first property. So in discrete probability distribution, in continuous probability distribution, first property is same. That is f of x greater than or equal to 0 or P of x greater than or equal to 0. Okay. So what is second one? So this is a very important one. Integration over minus infinity to infinity f of x equal to 1. So our second property is integration over minus infinity f of x dx equal to 1. Okay. So our second property we can also written as like this, p of x dx equal to 1. But function is always denoted with f of x, that's why we can write f of x dx equal to 1. So this is our second property. So, how many types of probability distributions are there? Discrete probability distribution, that means probability mass function, or we can say that is probability PMF. So, continuous probability distribution, that is probability density function. That means PDF. Okay. So, these two are probability distributions. Based on these two probability distributions, we can find the problems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.